Hi everyone, Hayden from Anchore here again to talk about zero-day proliferation and how Anchore could help. So 0 days can be quite complicated just because sometimes there is a lacking of a CVE identifier that could be used to go and track 0 days as they come out. So a lot of times what happens is a 0 day is discovered in the wild, it is reported, and then we know about the impacted or affected package, and we still don't have a CVE identifier available in machine readable format for scanners to use across the board. So any form of automated vulnerability scanner will really struggle with identifying that impacted 0 day package without that CVE identifier. But with Anchor, the tables have kind of been turned in our favor, right? So with Anchor, it's actually really easy to go ahead and identify 0 days and see the proliferation of that 0 day across your environment, right? So a good place to start is with the reporting service that is included within Anchor 4.1.1. So here we can actually pull up an image. This is a test image that we have created during some Log4j testing and validation exercises. Um, it's a public image, so feel free to pull it and validate it with any scanner that you choose, right? But just to show you how quickly Anchor can go ahead and pull information about Log4j, we could walk through this rather quickly, right? So you could go ahead and get the visibility and see what specific version of that package is installed, which is really important because during 0 days, a lot of times there will be a initial period where people can identify, contain, and triage vulnerabilities in 0 days. But a lot of times there will be multiple or subsequent updates that follow the initial patch or fix because security teams are very eager to discover if there is an additional vulnerability in the patch or fix, as was the case with Log4j, right? So we can come in here and we could just click view images affected. So what this does is it does the relational data analysis for you in an automated fashion. And this is available over the API as well. So you can very quickly, as you saw here, in a matter of seconds, get an idea of where this vulnerability persists throughout your environment. So here I could see that, let's see, I have 35 different uh, artifacts, right, that are impacted by this vulnerability. And you could see all the different locations that are provided uh, within the report itself, right? So although this may be the same image, you may have multiple instances within that image where an impacted package or 0 day in this case may nest itself or may find a home. So it's really important to have that artifact location so you can identify every single place where that package is installed within each piece of software that your team is producing. It's also important to make sure that, when you get that notification, that you're able to identify where it's running right now, right? So here we could filter on our vulnerabilities for our cluster, and we could just search for log4j, in which case you do not see this being impacted, which is really nice. So here I could go in and identify that in a matter of seconds, right? Um, Going back to that report really quickly. So let's go ahead and look at regenerate that report. We could take a look at something that's also really important, which is seeing where it gets introduced in uh, in the software development lifecycle. So we could go ahead and go to the vulnerabilities tab here. We could click on this right here. So you could see one thing that gets generated here is your registry, your repo, along with when the tag was detected, the impacted artifact version. So I see this repo here, which I know is stored in my application. So in the concept of Anchor, in the architecture of Anchor Enterprise, we have this idea of applications. So you could go in and create uh, source code repos that have an associated SBOM with those and then associated images. So in this case, I can go in and validate whether log4j was in the source code repo or is it not, right? So you go in and perform that check. So in which case I do not see it here. But if you look at the associated image tag that was generated in that report, what you'll find is that log4j was introduced in that CI step. So this is very reflective of how modern software development occurs, right? So you may have source code somewhere, it may look clean and may be fine as of, one morning, and then when a CI job kicks off and they actually compile that software and build it into the form of an image, that they want to then go deploy in the form of a running container in Kubernetes, that's when additional software can get added. And with that additional software can come additional vulnerabilities, or in this case, a 0-day, right? So I could see, okay, I didn't have that source code impacted 0-day in that source code, but I do have it now within this image, which tells me that this was introduced by my developer. And furthermore, it tells me this wasn't introduced by my parent image. It wasn't introduced by a protected gold image or base image, because I could look and filter on this right here and see that this log4j vulnerability was not inherited from my base image, which is really, really important here. So that's kind of a 0-day preparation walkthrough and how you could go through identifying and triaging uh, 0 days in the event they impact your organization.